Friends, so today we are going to discuss Ohm's law, that graphical representation of Ohm's law. That what is a statement of Ohm's law we have discussed earlier. Okay, so Ohm's law has given the relation between potential difference and current, how potential difference and current are related to each other, and Ohm's law said that current is directly proportional to potential difference when temperature remain constant in any conductor. Through that Ohm's law we got one relation, that one is V by I is equal to R, where R is what? Resistance. And what is resistance? That one also we have discussed in previous class. Okay, resistance is what? It is the obstruction offered by a conductor to the flow of current, so that one is called resistance. So there is a graphical representation of Ohm's law. Okay, so when we are going to represent Ohm's law in graph, so in y-axis we are taking V, and in x-axis we are taking current. Okay, suppose current is given in ampere and potential difference is given in volt. Okay, now suppose we have one table in which we know the value of V1 and I1, like we have some observation. In that observation, by varying the potential difference we recorded the current. Okay, so let in this case we are considering V1, and that particular V1, that current is I1. Suppose when potential difference is V2, at that time the current is I2. When potential difference is V3, that time current is I3. So like that we have assumed one values, okay, in table. Now suppose I have to put this V1 and I1, V2 and I2 on the graph. So here I have marked in current in x-axis I1, I2, I3, I4 we have indicated. In y-axis I have indicated the potential difference value V1, V2, V3, V4, like that. Okay, now we have to make the point, like V1 and I1 is making one point, V1 I1. Okay, so suppose this one is V1, so we have to extend this V1, and this I1 also we have to extend, and we got one intersecting point between them. So that one is our point A. Suppose this one is point A, so this one is our point A. Now next point, suppose I have to find B. So B is what? Intersection of V2 and I2. So extend this V2 and also extend this I2 vertically. Now the intersection point between this one is V2 and I2, and this intersection point is B. Now again extend this I3 in vertical direction and extend this V2 in horizontal direction, and where it is cutting both, find the intersection point of V3 and I3. So this one is intersection point, and suppose this one is C. So like that we have to make the points, and suppose we join these points. So these points are making one straight line which is passing through the origin. Okay, so this is the representation of Ohm's law, and this one is called V versus I graph, potential difference versus current graph. Okay, so any conductor, okay, whose graph is like that, which obey this Ohm's law, that one is called ohmic resistance. So always you should remember that for ohmic resistance the graph should be a straight line and it should passes through the origin. Now one more point we have to consider here. Suppose we find the slope of this graph. Okay, suppose I have to find the slope of this graph. Okay. So first I am going to explain what is slope. It is indicated by M, and this slope is equal, this slope is equal to tan theta. Actually tan theta means perpendicular by hypotenuse. Suppose we have one line. Okay, now suppose I have to find the slope of this line. So how we can find the slope of this line? Either finding tan theta or finding MP by H, perpendicular by hypotenuse. Okay, So suppose this line, suppose I complete this line like this, so it will make one right angle triangle. Okay, so suppose this height I consider P, and this one is what? Our horizontal base, P by B, sorry, it is P by B, perpendicular by base, so this one is our base. Okay, so suppose I have to find slope of this line, this L1 line. Okay, so slope will be equal to what? P by H. So now suppose from this graph we have to find the slope, so what we have to do? We choose any point A, B, C. Suppose I want to choose this point C. So through this point C, draw one horizontal line and one vertical line. So this will be our P. Okay, and what is the value of P? I am not writing P here, I am writing the value. What is the value of P? This one is V3. Okay, and what is the value of this base? This base value is I3, because it is going up to I3. So suppose I find slope, so slope is equal to V3 by I3, or in some term it is written as slope is equal to, in we can write V by I. Okay, so the VI graph, when we are finding the slope of VI graph, we will get what? Resistance, because V by I is equal to what? R. Here I have told you that now V by I is equal to what? R. So whenever we are finding the slope, we are getting what? R. So V by I is equal to R. So slope of VI graph will give you resistance of a conductor. Suppose we choose any point. Okay, suppose I want to choose these 2 points. Wait. Suppose I want to choose A and C point. Okay, so from A, draw one horizontal line and one vertical line. Now we have to find this perpendicular height, and we have to find this horizontal length. Okay, so what is the horizontal length of this point? It is what? Total length is I3, and up to this it is I1. So we can write I3 minus I1, and here we should write V3, because total height is V3, and in that V3 we have to minus V1, so V3 minus V1. Okay, so in this case we write like that: slope is equal to V3 minus V1 divided by I3 minus I1. That's why in book it has written like this: change in potential difference divided by change in current. Okay, so it is also okay for the slope of VI graph, and it will also give you what? Resistance. Okay. Okay, now let's understand this by one question. Okay, so here is one question. In that question they have given you one table. In that table, this one is the first column is potential difference and second column is current. Okay, so when potential difference is 0.5 volt, the current is what? 0.2 ampere. So like that it has given. Okay, potential difference is given in volt and current is given in ampere, and we have to find resistance of this conductor. Okay, so for finding the resistance of this conductor, first we have to draw one graph. I am roughly drawing this graph. So hey, in this side we have to represent current, and this side we have to represent potential difference. Okay, so our potential difference is 0.5, 1, 1.5, 2, then 2.5. This side we have to indicate current I. So current is 0.2, 0.4 ampere, 0.6 ampere, 0.8 ampere, then 1 ampere. Now we can make point through this V and I table. Okay, so first point we will get what? 0.5. Oh no, sorry. See, here in x axis we have current, so first we have to write the coordinate of x, means x axis. So in x axis we have consider what? Current. So we have to write the coordinate of this current first. Okay, 0.2 comma 0.5. As we know that in coordinate point we have to first indicate x coordinate, then y coordinate. So 0.2 and 0.5. Suppose this one is point A. Our next point is 0.4 and 1, then 0.6 comma 1.5. B, C, here it is 0.8 comma 2, D point, then 1 comma 2.5, that one is our E point. Okay, so now indicate these all points on this coordinate axis. Okay, so our first point is what? Intersection of 0.2 and 0.5. So this one is our first point. Second point is our 0.4 comma 1. Then next point is 1.5 and 0.6 and 1.5, then 0.8 and 2. So this one is 2 volt and there is 0.8. Then our next point is 2.5 and 1. Okay, when you draw this all data in graph by taking suitable scale, then you will get one graph, okay, which is linear equation, a linear graph, a straight line which passes through the origin. Now join these all points. This one is A point, B point, C point, D point, E point. So when I join these all points, we will get one straight line which is passes through the origin. Now choose any point and find the slope of this graph. Okay, suppose you choose any point, you will get the same value. Suppose I want to choose C point. Okay, so through C, draw one vertical line and one horizontal line. Okay, and what is the height of this vertical height of this line? It is 1.5, and in horizontal it is 0.6. And I have told you that slope is equal to what? P by H. So P is 1.5 and H is, sorry, P by B, not H. P by B, perpendicular by base. So base is here 0.6. So we will get 15 by 6. So it will come 2.5. And what will be unit of this? See, this is in volt and this is in ampere. So we will get volt per ampere, and volt per ampere is also known as ohm. Okay, so 2.5 ohm we are getting. Okay, suppose you choose point D. So through D, suppose you draw one horizontal line and one vertical line. Okay, so this this vertical height is how much? 2 volt, and horizontal length is how much? 0.8. This total length is how much? 0.8. So suppose in this case also, suppose I find slope, so 2 divided by 0.8, so it will come 20 by 8. Again it will come 2.5 ohm. So This is constant, means whenever any point, suppose you choose any point and find the slope, you will get the same value. Okay, so that one is our resistance. So through this I have proved that if we find the slope of vi graph, we will get the resistance of a conductor. Now we have to discuss about ohmic resistors and non-ohmic resistor. So first I am going to explain what is ohmic resistor. So ohmic resistor is what? The resistors which obey Ohm's law. Okay, the resistor which obey Ohm's law, that one is called what? Ohmic resistance, like copper, aluminum, silver, nichrome wire. Okay, so there are lots of conductor, okay, which metals which obey the Ohm's law, so that's why it is called ohmic resistor. And the graph of ohmic resistors is like that. Okay, V and I. So this one is the graph of ohmic resistors. Now what is non-ohmic resistors? Okay, so non-ohmic resistor is the resistor which do not obey Ohm's law. Okay, which do not obey Ohm's law. So that type of resistor is called non-ohmic resistor. Okay, example we can write LED, solar cell, then diode, transistors. Okay, so these are some examples which are called non-ohmic resistor because they are not obeying the Ohm's law. And the graph of this non-ohmic resistor is not linear. Okay, it is like some curve path. It will be like that also, or it will be like that also. Okay, so that one is called non-ohmic resistor. Some note is there. You have to note down this one. For ohmic resistor, it is necessary that the straight line on VI graph should passes through the origin. Okay, so it is necessary condition that for ohmic resistor, the straight line on VI graph should always pass through origin. Then it should called as a ohmic resistors. This you have to remember that so many times it has asked that question. Okay, now let's discuss about the factors affecting the resistance of a conductor. Okay, so first factor is length of a conductor. So how length and resistance is related? Actually, resistance of any conductor is directly proportional to its length. So what is the meaning of that? If length is going to increase, then resistance is also going to increase. Okay, suppose we have two wire, this one is 1 and this one is 2. Okay, second wire. Now this first wire has length L and this second wire has double length, okay, 2L. So suppose its resistance is R1 and its resistance is R2. So in this case, which one is more? R2 is greater than R1 because length of second resistor is more as compared to length of first conductor. Now second is what? Thickness of a conductor, or it is also called cross sectional area of a conductor. Okay, so thickness is what? कोई भी लेंथ, कोई भी कंडक्टर का मोटाई. ठीक है. So the resistance of any wire, okay, is resistance of any wire is inversely proportional to its cross-sectional area or thickness of the wire. So whenever we are increasing area, cross-sectional area or thickness of any wire, its resistance is going to decrease, because this one is in denominator. So whenever we increase the value of denominator, this value is going to decrease. Okay, that one is inversely proportional. So the wire which is more thick will offer less resistance, and the wire which is thinner will offer more resistance. Okay, now what is cross sectional area? Let's understand that. Suppose this one is one wire, and suppose we see this wire through this side from its front side. So how it will look? Its cross section area will look like one circular. Okay, one circle. So suppose this one is our cross sectional area of the wire. Let's this wire has radius r. Okay, so what is the cross section area for this wire? Suppose it has radius r, it is pi r square. So we should remember this one. Okay, so pi r square. So indirectly that resistance of wire is actually inversely proportional to a square of radius of wire. Also we can say that. Okay, here we can write like that: r is directly inversely proportional to a, or r is inversely proportional to pi r square. So this pi is constant, so we can also say that inversely proportional to r square, radius square. Okay, so whenever we increase the radius, this resistance is going to decrease. Now when we combine these two, this one, suppose this one is equation 2 and suppose this one is equation 1, r is directly proportional to l, r is directly proportional to l, and r is inversely proportional to cross sectional area. When we combine these two, we will get r is directly proportional to l by a, and when we remove this proportionality constant, we will get r is equal to rho l by a. This one is one important expression. Okay, where rho is called resistivity. Okay, resistivity or a specific resistance. Okay, and this one, it is this specific resistance, it is a material properties. Okay, for any material it is fixed, it is not going to change with length and cross sectional area. You should remember that. Okay, it is the characteristics of material. Okay, now through this expression we can define the resistivity. So r is equal to rho l by a. Now suppose the conductor, okay, whose length is 1 meter and its cross section area is also unit cross section area. Okay, means 1 unit. A length is also what? 1 unit. For unit length and unit cross sectional area, okay, one conductor is there whose length is 1 unit and cross section area is 1 unit. So at that time r will become what? r will become equal to rho. Okay, so through that we can define the resistivity, and the definition of resistivity. So a specific resistance of a material is the resistance of a wire of that material of unit length and unit area of cross section. So that one is the definition of a specific resistance. Okay, now let's explore this equation more. Okay, r is equal to rho l by a, or we can also write that r is equal to rho l divided by pi r square, where r is what? radius of wire. Okay, L is what? Length of wire. Okay, so through this expression we notice one thing, that R is equal to rho L by R square. This side, suppose there is pi, this one is L. So this rho and pi, this one is not going to change for any material. Okay, for copper it is fixed, rho is fixed, and pi is what? Constant. So which is going to change? This L and R square. Okay, so suppose in any wire, suppose this one is one wire whose cross sectional area is A and its length is what? L. Okay, now suppose I elongate this wire, मतलब इसको हम खींच के क्या करेंगे? लंबा कर देंगे, जो इनिशियल जो लेंथ था उसका डबल लेंथ कर देंगे. ओके, जो इनिशियल लेंथ था उसका क्या कर दिए हम? डबल लेंथ कर दिए. सो दिस वन इज 2L. सो देखो, when we increase the length, this radius or this cross sectional area is going to what? Decrease. Okay, this radius of this wire is going to डिक्रीज. एंड देखो यहाँ रेडियस कैसे डिक्रीज हो रहा है? स्क्वायर में. ठीक है, और लेंथ. ओके, सो इन दोनों, ये एक टर्म क्या हो रहा है? इंक्रीज हो रहा है, और दूसरा क्या हो रहा है? डिक्रीज हो रहा है. ठीक है, तो कभी भी लेंथ को अगर हम डबल करेंगे तो जो क्रॉस सेक्शनल एरिया है वो क्या होगा? हाफ हो जाएगा, A/2. ओके, तो ये हमेशा याद रखना. ओके, वेन एवर वी डबल the length, wait, here I am writing, whenever we double the length of same wire, its cross sectional area will become half of initial cross sectional area. Okay, so let's do one question related to that. Okay, so here one question is there: what is the change in resistance of a wire whose length is double to its initial length? Okay, so in this question it is asking that what is the change in resistance of a wire. Okay, suppose we have changed its length to double. So suppose this one is one wire. Okay, now initially its length is what? L, and its cross sectional area is what? A. Okay, now when we double its length, so we have increased the length 2L, and now its cross sectional area will become what? A/2. मतलब thickness कितना हो गया? हाफ. ओके, एंड बोथ आर सेम वायर, बिकॉज इनिशियली जो वायर था उसी को हम क्या किए? डबल लेंथ किए हैं, उसी को एलोंगेट करके. ओके, सो मतलब इसका स्पेसिफिक रेजिस्टेंस क्या होगा? सेम होगा, रो एंड रो. ओके, सो लेट्स राइट द resistance formula for this wire. Okay, so we can write R1 is equal to rho 1 L1 by A1. Here rho 1 is, we are considering rho because rho is same for both the wire, because both the wire is same. Okay, so rho into L divided by A. Now write the expression for R2. So R2 is equal to rho 2 L2 by A2. Rho 2, again we will take rho, then L is what? 2L. Now length become double, and this cross sectional area become A/2. So we can write like that: 2 rho L into 2 by A, or we can say that 4 rho L by A. Now R2 is equal to how much we got? 4 rho L by A. And this rho L by A, from this equation we can see, suppose this one is equation A1. Okay, so through that we can write that instead of rho L by A, we can directly write what? R1. So 4 R1. So what you have observed, that this resistance of second wire will become 4 times the resistance of first wire. Okay, so through this we conclude that whenever we increase the or we double the length of any wire, its resistance is going to increase how much times? 4 times its resistance is going to increase. That one you have to remember that. Okay, now let's discuss the unit of resistivity. Okay, so unit of resistivity or specific resistance, rho. Okay, so we know that R is equal to rho L by A. Through this expression we can write rho is equal to R into A divided by L. Now what is the unit of resistance? We know that it is ohm. Then unit of this one is area is what? Cross sectional area is meter square, and the unit of length is what? Meter. So this meter square and meter is cancel out and it will come ohm meter. Okay, so SI, unit of a specific resistance or resistivity is ohm meter. Okay,